Welcome back for section 1-5. So once again, I'm going to split this into 2 days for us because there's a lot of material to cover in this section. So today we're focusing on solving inequalities, and specifically our learning target is going to be to solve and graph inequalities. So let's review what we would have done back at the expo level, okay? So let's just review the language of how we'd read these statements. So each of these I'm going to say is X is, so I don't have to rewrite that every single time. So in this case, our symbol, X is less than 2, right? And when it's strictly less than a value, we use an open circle to show that, right? And then less than will obviously point going towards smaller numbers. Here, this symbol is greater than, but it also has the equal to. So greater than or equal to 5. Okay? So here, I'm going to have my 0, 1, 2, 3, 4, 5. What is greater than or equal to? Remember that equal to means we have a closed circle. Okay? Now, another way to write this would be at least. Okay? So is at least 5. So here, what about this? Well, this is strictly greater than. So again, strictly greater than without the or equal to will be an open circle. And what about this one? Well, this one is less than, but it also has the or equal to -1. So again, the or equal to means it does get the closed circle. Less than looks like that. I think this one also has another version of it. You could say X is at most -1. Okay, so those or equal to's also have these other phrases that can represent them. Do make sure you write those down because you may come across them in homework or in the future notes. Now, for this last one, it's always easiest to deal with inequalities if your variable is on the left-hand side. So this is written oppositely of the way that I want it, okay? So what I would do is I would rewrite this. I would flip the x and the 4, but when you flip it, the direction is also going to flip with it, okay? So reverse your sides and reverse the inequality, and then it becomes one you've already done, okay? This is going to be the situation that we actually just finished covering. Okay, x is at most that, or less than or equal to, so you'll get your line like that. Okay, it is important that you recognize it's easiest to identify the direction and everything when the variable is on the left-hand side, okay? Just makes everything easier. All right, so what inequality represents each of the following situations? The product of 7 and a number. So I'm just going to call that number n, just because it doesn't say what letter to use. Okay, and it is no more than 50. Okay, so that's telling me it could be 50, or it could be less than 50, but it can't actually be 50. Okay, so that's what that's communicating to me. Or what about this? Quotient of a number and 3, quotient meaning division, is at least. So at least means it could be equal to 15, but other than that, it has to be greater than. It could be 16, it could be 17, it could be 18. And you would want to write it like that. Okay, so kind of just like what we were doing back in 1-3, I do expect that you can write these situations for me. If I give you a word statement, you can write the mathematical statement that goes with it. And the last thing is, remember, you need to reverse the inequality sign if you multiply or divide by a negative. Okay, so that is going to be important to remember that you have to do that. So otherwise, the bulk of today is just discussing how do we solve these inequalities, okay? And from the most part, you solve them just like you would a normal equation. Same type of process. Clean up the sides, see if you need to bring your variables together, otherwise just do the reverse operations, all right? So for example here, I'm going to distribute that 4. 4x minus 28 is greater than negative 20. I'm going to add 28 to both sides. So 4x is greater than 8. Divide by 4, you get x is greater than 2. And if I were to put that on a number line, just greater than is going to be an open circle going towards the larger numbers. All right, middle example. Again, let's clean up that left-hand side. So I'm going to get negative 2x minus 18 plus 5 is greater than or equal to 3. Let's blend those together. So I have negative 2x minus 13 is less than or equal to, or is greater than or equal to 3. Add 13 to both sides. Negative 2x is greater than or equal to 26. And now divide by negative 2. And here is the important thing. I just divided by a negative number. Because I divided by a negative number, what that means is I have to reverse the direction of that inequality, okay? So completely turn it around. Now I have my solution. So if 0 is down here, oh, I'm sorry. I'm going to want 0 up there. Negative 13 would be somewhere down there. Less than or equal to. The or equal to means it's filled in. Less than means it's pointing towards the smaller numbers. All right. So let's talk about this next one. Well, the next one has multiple ways you could go about solving it, okay? Now, for the sake of this one, I'm going to say probably you don't like working with fractions, okay? That's going to be the assumption that I'm going off of. So I'm going to show you how to get rid of that fraction, okay? Well, for starters, let's subtract the 3 over, okay? So I'm going to have t divided by 2 less than or equal to 3t. Negative 5 minus 3 is going to be a negative 8. Okay, so I'm going to move it away from that fraction. So now that I have that t divided by 2, now I'm going to be ready. I can multiply the entire equation by 2. All right? So I'm going to multiply the whole thing by 2. Okay, so now my fraction is gone. Makes it a little bit easier to work with. I know you guys aren't the biggest fans of fractions. So now I want to bring the t's together, okay? Now remember what I said. It's usually easiest if you bring it to the left-hand side. So I'm going to subtract 6t from both sides. So 1 minus 6 is negative 5. So now divide both sides by negative 5. Negative 16 divided by negative 5 is going to be a positive 3.2. But keep in mind, I also just divided by a negative number. So I also do have to reverse the direction of the inequality. Now that I have that, now I'm ready. Now here, don't be afraid of the fact that you're dealing with a decimal. Decimals happen in the real world, okay? It's fine. So I'm just going to approximate as best I can 3.2. It's going to be about here. Greater than or equal to. The or equal to means I give it a filled in circle. And it's greater than that. All right, so let's talk about a couple word problems, okay? So plumber A charges $75 for a service charge, $40 per hour. Plumber B charges $50 per hour without a service charge. How many hours must the plumbing job last for plumber A to cost less than plumber B? So I'm going to do plumber A. I'm going to represent his in blue. So plumber A has an initial charge of $75 and then 40 per hour. Plumber B has no initial charge, but it's just 50 per hour. And I want to know what it's going to take for A to cost less than B. So A to be less than B would look like that, okay? And now from here, I just have an inequality to solve. So I have my x's on both sides. So I'm going to subtract off the 40x from both sides. So 75 is less than 10x. Now divide by 10. Now again, usually is easiest when a variable is on the left. But again, when I reverse it, I also have to reverse the direction of my inequality. So that gives me when x is greater than 7.5 hours. So if the job is more than 7.5 hours, if it's greater than 7.5, then you are going to want to go with plumber A. All right, a digital music service offers 2 subscription plans. The first has a $9 membership fee and charges $1 per download. The second has a $25 membership fee and only charges 50 cents per download. How many songs must you download for the second plan to cost less than the first? So again, to set this up, I'm going to set it up very, very similarly to the way I had it previously, okay, on the last one. So the first plan has a $9 membership fee, so you just pay the $9 and $1 per download. The second plan is a $25 membership fee, and it's 50 cents per download. And I want to know how much you have to spend for the second plan to cost less than the first. All right, how many downloads do you have to do? All right, so let's get started. So here, I think it's easiest. let's bring our x's together. So I'm going to subtract off 0.5x. So I was going to leave me with 9 plus, well, 1 minus 0.5, oops, is still 0.5. Now, let's move my variables, or sorry, not move my variables, move the other number away. So I'm going to subtract 9 from both sides. 25 minus 9 is going to give me 16. Now here I can divide by 0.5, or that would actually be exactly the same as multiplying by 2. So if you plan on downloading more than 32 songs, then plan A, or the second plan, will be less expensive than the first plan for you. Now, I do also want to take just a quick minute to talk about the special cases that can arise. Okay, so just like when the variable canceled off from an equation, the same two cases actually apply to inequalities, where it's either no solution, or in this instance, it's called all real numbers instead of infinitely many solutions. Okay, slight difference, but it's the same idea. So let's take a look. Here, I'm going to distribute the 3. Here, I'm going to distribute the 3. And what's going to happen? Well, I'm going to subtract 3x from both sides. And that's going to leave me something like that. All right. Now, 9 is greater than or equal to 6. Well, that is a true statement. Okay. In fact, that is always a true statement. So just like before, when you're left with something that is true, that is going to be all real numbers, okay? Or infinitely many solutions is the equivalent idea from equations, all right? But the idea is when it's true, any x would have worked. Well, the opposite of that is still true as well. So let's take a look here. 9 minus 5 is positive 4. So I'm going to add an x to both sides. So 4 less than 4. Now this one you may be thinking, hey, awesome, both are 4s. But really take a closer look at what it's saying. 4 is less than 4. Well, that's just simply not true. 4 is equal to 4, not less than it. So this, despite looking halfway true, is actually false. 4 is not less than 4. So that means there is no solution. It doesn't matter what x originally was, it is going to be false. No x will make it true ever. Okay? So then I just wanted to make sure to point out the parallels that equations have to inequalities in those special cases. All right, otherwise, that is all for today's notes. So, as always, do take a moment here and write out your summary for me, and then come back ready to do your practice work in class.